Number 61 here isn't going to take that much work, but it does take a lot of thought. And I got to be honest with you guys, this is the kind of question that the AP writers love to come up with right here. Ones that kind of make you scratch your head and say, wait a minute, do I really understand what's going on right here? Our directions are just to express each integral, probably should say integral expression, as a single integral. So our answer here is going to be, okay, this subtraction expression could just be rewritten as one single integral taken with respect to x. The question really here is, what are the limits of integration? So let's see what's going on. The property at work here, guys, says the following, and this is in your notes, that an integral from, let's just say, from a to b of a particular function, doesn't matter what the function is, taken with respect to x, added to an adjacent interval, one that starts where the previous interval stopped. So I'll go from b to c of the same integrand, f of x, taken with respect to the same variable, can be rewritten now as one single integral that starts here at a and ends here at c. A and c, and the integrand and the variable of integration stay exactly the same. So what's going on in this problem, guys? If we look at our limits of integration, I think we can all see here's a 2, here's a 9, here's a 5, and that 2 gets used again. So what's going on right here? A, if I go back to this line right here, is the smallest number out of the 3, the furthest to the left. That's going to be like the 2 in this problem. So our A becomes a 2. B is the middle out of the 3 values of a, b, and c, so our b value is actually going to be 5. An integral from 2 to 5 of f of x dx, added to an integral now that starts where the last integral stopped, b is 5, and ends at c, which is the highest of these 3 values, which for us here is going to be 9. So the integral from 5 to 9 of f of x dx, we can add those two integrals together and get one single integral that starts at 2 and ends at 9 of f of x dx. Now, take a look at the expression that they gave us, everybody. They've got the integral from 2 to 9 minus the integral from 2 to 5. So here's the integral from 2 to 9, but they're now subtracting this integral right here. So I'm going to subtract the integral, from 2 to 5 of f of x dx from both sides of this equation. Integral from 2 to 5 of f of x dx. So that term cancels with that term, and where are we now? This guy comes straight down. The integral from 5 to 9 of f of x dx is equal to, and I'm just going to rewrite this, an integral from 2 to 9 of f of x dx minus an integral from 2 to 5 of f of x dx. And that, if I'm not mistaken, is exactly what the original expression they wanted us to evaluate was. So what does it equal? This quantity right here. So our answer is the integral from 5 to 9 of f of x, and there was my dx. So that, guys, is the answer here to problem number 61. So all we had to do was set up an original statement right here using that additivity property for adjacent intervals, and then figure out what our a, b, and c values were to come up with this statement right here. An integral from 2 to 5 plus an integral from 5 to 9 could just be rewritten as an integral from 2 to 9. And then we just had to use basic laws of algebra to get this expression here worked out and figure out what was left over. So that is number 61.